Hello, hello. Is this, wait, son? No, the room one. No. Okay. Hello, hello. Okay. You shut the door. Get in. Just made it. Okay. Just a reminder, please complete my experience. 22% of you have completed it. We need to hit way higher. That's not that good. Hopefully all of you have done it. If you haven't, please just complete the survey. Nothing more to really say on that. All right, what are we going to do today? Finish off this book program. I'll do a recap of the program where we got to on Monday before Raveen gave his ICPC demo, which was really cool. Anyone sign up for ICPC? Couple people? Good. Actually, just one person. Is that right? Or I don't know. I think it was really cool. So, man, if you wanna destroy programming interviews in a few years, I think ICPC is the way to do it, right? Yeah. So, good job, you. Yeah, we'll do this demo. We'll get to where we want to get to, and then I think what we can do is add sort of extra stuff to it that might be slightly out of scope of the course. Maybe like file writing and reading and things like that. Sound good? Looks like a lot of you have decided that your test study is more important than this lecture, which is fair enough. Anyway, okay, so here's the demo program. This is exactly where we left it off on Monday. So it's a linked list of a bookshelf. So the shelf is a linked list of books. What we want this linked list bookshelf to be able to do is insert books into the shelf and take books from the shelf, but in order. And we said what we want that order to look like is something like genre and then alphabetic. So the books will be clumped by their genre. And then within that clump, the books will be inserted alphabetically. So we haven't done any of that inserting yet. We just construct the books in the bookshelf somewhat randomly. That's what we want to do at first. We order on insert. That's important. So I did mention there's two general ways to do sorting of a data structure like this. You can order it on insert. So every time you put something into the structure, you spend a bit of time making sure it goes in the right place. And that's good because it means, can you just pull the door, please? And that's good because it means that the shelf is always guaranteed to be sorted because a book won't be able to go in there without going in the right place. Another strategy, and we can even look at doing this strategy, it completely depends on how fast we go, is that you sort of put the books randomly at the end. Think about like a messy local library. And then every so often, you spend the time reordering the shelf. And it's a trade-up. There's no right way or wrong way. It depends. If your data structure is books are going in, 1,000 times a second, if you spend the time to order it every single time, you might actually fall behind. Does that sort of make sense? So it depends on the use case of the data structure, what you might like to do. So, but we're going to start with adding sorted, which makes a lot more sense for us. Yeah, so sorted by genre first and then title. And then we want to make sure we can insert books, remove books, print the bookshelf, and do stuff like that. So where did we get to? So we set up some of the data structures. This is what we had set up, basically. Shall we run through this a little bit? We have our imports. That's pretty boring, nothing going on there. We have the maximum length of a book's title, just because we're creating some static arrays here. And we're just saying 100 characters. Probably not enough in reality. You can just increase that if you like. We have an enumeration to store the genre. So every book will have a genre. And this will come in handy when we're doing the genre sorting, which we've got to think about. All right. Different from all the other lecture linked list demo programs, we are storing nodes of books. And the book here is a struct. So this is pretty straightforward as well. We have a struct book that's got a title, which is the string. We have pages, which is an integer. And we have the category, which is that enumeration. So that is the data stored in each node. And then we have the node itself. And the node you've seen many times by now. We store the data, which is the book, and the pointer to the next node in the linked list, in the bookshelf. Cool. Any questions on that setup? Pretty straightforward, I think. All right. Some of the functions we wrote. We have this create book function, which just creates the struct book given some data. And we use, just a reminder, for strings, we have to use string copy to assign the string. We can print a book to the terminal to standard output. Remember, when you're dealing with enumerations, you have to have a bit of an annoying if statement here to check what string we actually want to print. We print, here's printing the entire bookshelf. So it's iterating through each node in the linked list and calling print book each time, basically. Maybe that would look better like that. I don't know. And then we print null at the end. Create a node, again, really straightforward. We've seen that a million times before. And I've just created a little helper function here to create the starting shelf. And all I'm doing here is creating a few books, three demo books, and putting them in a random order. Although we should think about the fact, I guess, yeah, it doesn't matter that they're not sorted because they're 3 different genres. So there's no way to sort this bookshelf at the moment. All right, then we return the shelf here. So in main, it's really simple. We create the starter shelf. We store that back into a pointer called shelf, right? And we print it. So let's run this. And we get Jake's Amazing Bookshelf. The first book is the Clean Code horror book, Crime and Punishment, which is a crime book, and then The Lion, the Witch, and the Wardrobe, the fantasy book, and then Null, which I don't like that Null. Let's get rid of that. And now the other thing I'm going to do is just move program.c to bookshelf. Yeah, I just renamed it because I didn't like it being called program. All right, so we have a bookshelf. We have some books in there. I think it's time to create our insert in order function. So if we think about it, what parameters will this function need? Someone want to yell it out? So you said the genre. I wouldn't say that we would want to pass it directly the genre. We do need to pass it the genre, but via what? No. We're inserting a book into the shelf. What do we need? The book. Yeah, the book, which has the genre in it, right? But we don't want to pass the genre separately. So yeah, that sounds right to me. What else does the function need? Someone else? The shelf, the pointer to the bookshelf, so that we know where to insert it. All right. Let's do it down here. So will it return anything? That's the third question. What do we give the function? What does it return? Who thinks it should return something? You do? What do you think it should return? You think inserting a book into the bookshelf should return a single book? Which book would it return? Yeah, so you were 50% right until the end, and then you dug your grave. You said return the bookshelf struct. So I like the bookshelf part, but not the struct part. What should we return? Yeah. We just re-return the bookshelf, but not a struct. It's the pointer to the first book. Why? Because we've changed this. We've changed the linked list, and we need to return a reference to the first book again, the head book. You were right. It's just the word struct was not quite right. All right. So that means we want to return a struct node. Insert book. What did we say it needs to accept? The struct book. I'm going to call it to insert. And what else? You're thinking? Do you have an answer? You. Yeah, you. Yeah. We're inserting a book into a bookshelf. What do we need? The bookshelf. Yeah? All make sense? Strong nod there. That was very good. All right. We got to think a bit here. So remember, the idea is we can have like book 1, book, or that could be like genre 1, genre 2, genre 3. We want to find the right genre, then within the genre, find the right alphabetic position. So how would we do this? Do we have any ideas? Someone want to describe? Maybe, when you're doing something like this, you can think, imagine that you were physically standing in front of a bookshelf that was sorted like this, but you could only go through, the problem like sometimes when we map our logical thinking to programming thinking is you're like, oh, just find the right spot. But that often involves like we scan, rescan, go back, go forward, overshoot, come back. If you think about, you can only start from the left and look one book to the right at a time, but you know that the bookshelf is sorted, what would you do? So let's say we're inserting, let me run this program. What just happened? Why is there also, oh, that needs to be resaved to bookshelf. And I need to remove program.c, and I need to then yeah, that's fine. We haven't finished writing that yet. So we've got this bookshelf. We've got a crime book, a horror book, a crime book, and a fantasy book. Let's say I'm inserting a crime book. What would you do? Or, but you've just overshot it. We don't know where the crime section is. Right, I said we only see, like, how about this? This is all you see, because you're starting on the first book. All right? So what do we do? Let's just speak in human terms. All right, you're standing in front of this bookshelf at home. You want to insert this book in the crime, but for some reason you've got very limited vision and you can only see one book at a time. Thank you. Yes, we keep going until what? Until we see a crime book. That's perfect answer. Or I'll just add the or, because you make the assumption that what? That there is a crime book. So let's find the first crime book or the end of the shelf. Okay, so we start here, then we go like this. I'm like, oh, great. That's a crime book. Now we got to decide, do we put it to the left or the right, right? Agreed? I'm actually not quite, I'm still thinking this through as well. But yeah, anyway.
Take the first character of the title and do like a less than or equal sort of.
So compare what you just said was compare the titles of the book I'm holding and the crime book, Crime and Punishment. And if my title is greater, let's figure out what that actually means in code later. But if it's alphabetically later in the alphabet, what? Put it in the right. But what's the problem with that? Well, that's a specific problem. That's not what I meant. Forget the starting letter part. Let's just say we can compare the whole title. But what's the problem? No, we can rearrange the pointers. So the answer you said was we have to, what did you say? rearrange the books. But we don't need to worry about that because the linked lists are great because they let us repoint things. No, there's a bigger problem. Yes, yes. There could be another crime book that we should put our book after that. Is that what you meant? Yeah. Do you see? We don't know what's next. So I think what we have to do is what? Check the next book. All right. Now we come across a different genre, so we know certainly that the new book has to go between Crime and Punishment and The Lion, the Witch, and the Wardrobe, for sure. If that was another crime book with a lower alphabetical title, we would have to do that again. So there's actually, I'm pretty sure, there's a simple, well, it's not too simple, but there's a single while condition we can form that does this check for us. But let's start writing and see when we get there. So we're certainly traversing through the linked list, one book at a time. We have to compare the titles somehow. We do know how to do that, but it depends if you guys remember. And we've got to check that the genre is the same or not. Then we've got to think about edge cases. So no genre, empty bookshelf, right? All this stuff we've got to think about. All right, but do you see that exercise? Do you see how easy it is when you're thinking through a problem like that to just be like, insert the book? Like, our brains do so much, but we got to sometimes slow it down. All right, anyway. Okay, so let's get writing here. So insert the book. So we know we're traversing the bookshelf, so I'm going to start off by creating a current pointer to the start of the linked list, the head pointer, because we can use current to traverse. It's a pretty safe start here. So struct node current is equal to the shelf, which is the head pointer in this case. Yeah? All right. Now, depends if we want to be clever or not. I mean, it's the second last week of term, so we can think about the edge cases as we go. So what happens if we have an empty bookshelf? Nothing. No, you still have a bookshelf, but there's no books in it. Add the book. Yeah, exactly. Now, do we have an insert? No, we can just do it here, I guess, in place. All I was thinking here is we could create a function that you pass it current, but that's unnecessary here, and it would insert it. We'll see. Anyway, so all I think we do is we say current. Whoops. Well, actually, we've got to create. Oh, that should also be like that. Oh no, never mind. We've got to create a node from this book first. Do we have a create node? We do. I think that's actually it. Well, we haven't got the if statement, but we create a node from the book and we return it. That becomes a new shelf. So in fact, we can just do return that, I think. But we only do this if what? Current is null. Very good. Was that you? Who was that? Yeah, good job. Yep, we have an empty bookshelf. All right. Now we know we don't have an empty bookshelf. You know, I saw something actually the other day. When we have a function like this and we have an insert and we check for an empty shelf, you can actually do this like this, and it's technically more efficient because why? You don't need to create the current pointer if there is no books to iterate through. So I don't know, I kind of like it. It's a little different to how we typically structure it, but same thing. Okay, now we decide, okay, like now we can iterate. And we decided that we want to iterate through, what was the first part of our condition? Until we find the genre, right? Wasn't that you? No, who was, sorry. Who gave us the answer? Anyway, we want to find the first book which matches the genre that we have. Yeah. So which how do I compare the two genres?
Would it be like I can't remember exactly how the struct is, but is it like current dot genre?
Current arrow, yeah, but dot.
Yeah.
Data. So data, remember data is the book, next is the pointer. And then that should be like genre. Yep.
And then that will be equal to
Are you sure?
SQRCRV?
That's title. We're doing genre first. Not equal.
Oh,
Yeah. While the genre is not equal to the book. Oh no, it's called to insert. Dot genre. Right? So while the genres don't match, keep iterating. Do we see that? Yeah. So let's iterate. Current is equal to current next. So this will iterate through our bookshelf. Why don't we, when we do this, call print, isn't it print book, current data. Because we're going to just take our time, debug it as we go. But what I'm going to do in my starter shelf, I want to add, anyone got another fantasy book for me? Peter Pan. It's fantasy, yep. Should we do one more maybe? Let's do a non-fantasy book after the last fantasy book. Anyone got another horror book for me? Or what else? We got another. We can do. I'm not doing romance. I don't trust you guys. Comedy? What's a comedy book? You. What'd you say? UNSW? I don't know. Whatever. Right there, there, there. All right. Let's just test that. So we're not calling our new function yet, but let's just make sure that our bookshelf looks good. We got clean code, crime and punishment, language of the wardrobe, Peter Pan, and then the handbook. So what we're going to test first is inserting a fantasy book. And it's a nice test that we've set up to start with because we know that it won't just be at the end of the linked list because we've got a comedy book there. So it's got to be before the comedy book and after one of the two fantasy books we don't know yet because it depends on the title of our new book. Cool? All right. Okay, now next I wanted to test inserting a book. Insert a new fantasy book. So I need struct book. What's it called? New book? Create book. Okay, I'm gonna have to do this thing. All right, so we want to, someone give me another fantasy book, please. What is it? I don't know what that is. I don't even know how to spell that. The what? Anyone read this? Neither. No one's read it. It's a good book. All right, there's mandatory reading now for the course. Okay, we insert that into the shelf. Now, just to remind everyone, our insert is not finished yet. I just want to see that we print until we're no longer. No, until we get to the right book. Yeah.
Is that going to just be before the line which?
This has got to return shelf, right? Yeah. Sorry?
Is that going to be just before line which the wardrobe then?
Okay, good question. So where do we expect this to stop looping? Well, you've said just before the line which. Let's find out. Let me put a new line here. Let me do this. All right, so printing books until we find a genre match. We print Clean Code because it's a horror book. We print Crime and Punishment because it's a crime book. Then it looks like it stopped, but what's happened is we found the first fantasy book and then we stopped looping. So right now our linked list, our current pointer is pointing to the fantasy book. Yep. So now we know we're at the first fantasy book. Is everyone following? Thumbs up? Ish? Good, great. All right, what's next? What's the next? Let's forget about the code. We're at the first book that matches a genre. What's the next task? We have to start comparing the titles alphabetically. Exactly. If we're lower alphabetically, we need to insert it straight away. If we're greater, we need to traverse and check again. Basically, is the process. So how can do we have a tool? Because what you alluded at was correct but complicated. Because you said we can compare character by character. Because characters are integers, so we can compare two numbers. But that's we're going to have to loop through each character. What if the characters are different length, like the titles are different lengths? Do we have another tool to compare strings alphabetically? String compare. Does anyone remember it? Yeah. It compares two strings. What does it return? Yeah, so it returns an integer, which represents the difference alphabetically of the two strings in some quite rudimentary way, but it should be enough to serve our purposes. So why don't we just do this for now? Once we get to the right book, why don't we just do a single comparison just to check that everything's working? It's strcmp, I think. We give it the two strings. So we are comparing, I think we will do to insert dot title compared to, let's just do current and let's just print that. So we're just going to print that integer. The difference is 1. Which means that, let's think about this. If it's returning a 1, it means that the book on the right is later alphabetically. That's correct, right? A positive number means the book on the right has a higher alphabetic value. If we think about that, so we got crime and punishment, and we were inserting
So that means we
THEP. That's right. So P is after, sorry, T is after C. No,
isn't the L is the line.
what's the other book? Oh, it's The Lion, the Witch, and the Wardrobe. That's right. And P is after L. Yeah, okay, good. So I think that adds up. Why don't we, just to test that, make this like that, the A-riary. Now I think it should return a negative number, if my thinking is correct. Whew. Good. All right, get it? So we know that the priory of the orange tree, which I'm going to have to go read this term break, is falling alphabetically after the current book we're looking at, which means what? Is anyone listening?
Yes.
So what's the answer?
I don't know, but I was listening.
Good, I believe you.
We have to traverse.
We have to traverse again, I think. We have to traverse again. Yeah. Until we find a negative number. Now, I think there's another way to simplify that. I think we can say loop while the genres are not the same, but if they are the same, loop while it's not negative. Until it is negative, at which point we insert. We got to do an L check. Great point.
What if that fails before the other one fails?
Okay, great question. Fantastic question. What if this fails before the genre fails? Is that what you meant? Okay, but what do we need to know about and statements in an if in a condition like this? It has to be both. There's something else though. Say that louder. Guys, this is a very good answer, so let's listen. It checks the first condition before it checks the second condition, but there's something, you're spot on, and I know you know what I'm getting at, but there's more to it. It stops checking if the first condition is false. It doesn't stop. It doesn't check the second condition if the first condition is false. So for this condition to even run, we had to match genres. Yes? In fact, right, this is actually kind of interesting when you start getting into the world of maybe more software engineering. If you've got two conditions that need to be true in an AND statement, right? Any two conditions, and one of them is really cheap and one of them is really expensive, which should you do? Which should go on the left side of the AND statement? The cheap one, because if that fails, you don't even need to bother running the expensive condition. Fun fact, good chat. Anyway, I think this might be okay. Let's see. We could have a null problem, but let's sort that out later.
Doesn't the first condition also fail? Once we reach the correct genre, the first condition will give us 0. So we'll stop looping.
But that's a not equal to.
Yeah, so when we reach the correct genre, it gives us 0. We have an AND statement, but then we get 0. We'll try to check alphabetically once we reach the genre, at which point our current genre will be equal to.
Let me think here. While the genres don't match, we loop. So once they match, we won't iterate again. And then we loop while the genres match. I think you're right. Who was that? I think you're right, because we stop iterating. Because what would we need to do? We could do or the genres match and we're less. That would also work, but that's probably more complicated than a second loop. But I thought this was possible like this with one loop, but maybe I'm wrong. Maybe I got to check. Okay, let's think it through. So what Tim is suggesting to solve this problem here, yeah, we're committing to this. Or we'll always check both, because only one of them needs to be true. That's correct. Yep. Our tutors are deliberating here. We're going to see. To what? No, because then it's just going to do it alphabetically, right? Where's my phone? Because I wrote notes on this morning, actually. Let me have a quick look. But I didn't actually test it, so. Ah, I see. Yes, we do need to figure this out. So, okay. Why don't we first loop through until we're at the start of the right genre? I think that's correct. Yes? We like this? All right, I'll explain this in a second. We got a loop. We got to loop both times, I think. Or no, hold on, that should go after, right? All right, let's see what this does. Because what book are we inserting now? We're inserting the Priory, which is a fantasy book. Oh, that's a good point. We got to sort that out. So book 3 needs to come first, which it does. No, Peter Pan needs to come first, right? But it's T. Yeah, yeah. So Peter Pan does have to come first. So let's just do. Okay, that's step 1. Get the books in order. Now we're inserting the Priory. So this would be the right spot. P is after L. So the Lion, the Priory, P is after L. So we would want to stop on the Lion and the Witch and the Wardrobe. If this book started with an A to test it, now we should, if this is working okay, stop after which book? Which book? Peter Pan. Yeah, that's right. That's good. then we have to hook up the book. Who have I lost in the room? 2 honest students. Let's hide this function. Let's go through the function again. All right, let's think through this function. First of all, we check if the shelf is empty. If the shelf is empty, nothing really matters. We add the book, we just return back the pointer to that book, basically, that we create as a linked list node. If we do need to iterate through the bookshelf, we create our current pointer to point to the first book in the bookshelf. Whoops. All right, and then we have the first step. The first step is we need to loop while we're not at the right genre, okay? So while the genres do not match the book that we're trying to insert, keep iterating through. And I'm printing the book each time just so I can see where we're up to. Who's with me so far? So we're just checking the genre. Now, once the genres match, we stop this loop, which means we're at the first book in the linked list with the same genre, right? Still following? Yep, there's some nods. Now we have a second while loop that's a bit longer. Guys, can you keep the giggling, please, down. Now we have a second loop, and this loop is responsible for looping, so keep going next book by book, while the genres do match, because we're trying to find the right matching genre. Right, so while the genres do match, we need this because otherwise we will just keep going until there's new genres that don't match. And the book that I'm inserting, or the book that's in the shelf that I'm looking at, has a later alphabetical position than the book that I'm inserting. So when that's not true, we stop looping, which means the book that I'm inserting has a lesser alphabetical title, and it's time to insert it. That's right, I think. I said that right? Yeah. There's a lot of conditions we have to keep in our mind here. Which means we stop iterating, so current is now pointing to that book, and we can actually insert the book. So here I was just printing the difference, but I can say, or have I overshot it by 1 book? No, because this had to run before we iterated, and then I didn't print it. So I did overshoot it by 1 book, which means I think that's got to be current next. Then I can say current next is equal to, did I create a node? No, I didn't create a node. And it's going to point to current next. Current next is going to point to this. Whoops. Right? Now there's some extra null checks we need to do here, but let's go on with that. So let's insert that book, and then let's print the bookshelf again. All right, basically what we got to check here is this inserted correctly? Is it inserted correctly? It's not inserted correctly. We've got, it's inserted correctly. We've got Peter Pan is the first fantasy book. I've got the old spelling, that might be why. We can change that back and check that it goes after the line which, but we've got the Aori in the orange tree. A is less than L, so A should be to the left, then the Lion and the Witch in the Wardrobe, and then we have the non-fantasy comedy book. If I fix up that book to be P, oh, that's not right. That's gone one too many. So how do we fix that? Because the genre stopped being true. Oh. Yeah, is that what it is? Whoops, what am I doing? You reckon? We're not sure. Okay, that was right. But now let's change it back to A. That's right. Yeah, very good. Yeah. Let me change it back. All right, I think that's a decent start at inserting in sequence with genre and title. There's a few edge conditions that need to be checked. Finishing all the genres, inserting at the end of the linked list, stuff like that. But for now, that's a good place to leave it, I think. For the mid-lecture break. Should we take 5 minutes? Coffee, bathroom, come back, Kahoot. We've got some people speaking from Revue. Yeah, I'll see you in 5 minutes. Well, I'm not going anywhere, but you know. Remember, all the code is live synced. Oh, no, you can't. John, can you throw the second mic? Well, don't throw it, but. So you're going to need, it's a bit annoying, you're going to need 2 mics per, like, if someone's speaking, you need 2 mics. You need that one and the one that John's going to give you. Presenting? Yeah, we're just introducing what I'm doing. Have we got? It's really annoying. Hold it on. Yeah, we did.
Oh, that's okay. We can just project.
Should have charged.
Thank you.
Are you just blowing tonight? Tim, have we got a second mic? If you've got tape or anything, you could like wrap that around the handheld. I don't think we do. Yep, that's all right. That one, yeah, that one's okay. No, we're in a break for like 5 minutes, so just wait.
computer science students.
Guys, are you listening?
A society called CSE Revue. If you guys haven't heard of us, basically we put on a show every year. Our show this year will be in term 3, so next term. It's a comedy show. There's also acting, dancing, singing, and also a live band. And yeah, usually we try to include like a quirky computer science theme. Past examples are Microsoft Shrexel and Aladdin Arabian Bites. But yeah, it's a really great way to kind of like express yourself creatively outside of your computer science courses.
Yeah, so not only do you get to gain a bunch of new skills, which some are industry relevant, you also get to meet the nicest and funniest people out there and make like lifelong friends.
Yeah, and it's also a really good opportunity because the science theatre hire alone costs $10,000, and the society will be paying for that. You guys can just perform for free. If you guys aren't into performing, there's also backstage stuff. So if you're part of tech, you can make the stage background, you can make props for performance to hold, and you can also play with really expensive lights. You can play sound cues if you want, play sad hamster sounds or whatever you want.
Yeah, personally, I joined to boost my confidence and step out of my comfort zone. And truly it worked because I used to have stage fright, but here I am talking to all of you. So yeah, Revue has something for everyone. If you're not into performing, there's the tech team, as Sabina mentioned earlier. You get to play around with like lights, programming lights. Yeah. If you want to learn more about Revue, Revue has a show that's running tonight until Friday night. So check that out with your friends. You'll have a really good time. We have subcom recruitment out now. So if you go on our Instagram CSE Revue, you can click on the link tree and the form will be there. If you have any other burning questions, don't hesitate to ask us. We're more than happy to answer.
Just quickly, did anyone have any questions right now? Yes? Yes. So it's CSE Revue.
Anything else?
How do you spell review?
Thank you.
It's not the most obvious spelling. Thanks. All right. I don't want to hear you guys saying you've got no friends in CSE when you don't do stuff like CSE Revue and ICPC. Huh? No excuses. You got to do it. All right, Kahoot. God, what a dead crowd today. You guys are killing me. Yeah, play. Guys, you're playing against the tutors today. And Angela, you can you can compete. Have I given out? Yeah. Someone accosted me in the are you here? So I was walking up I was walking out of campus and someone was like, "You owe me a Pokemon card." I feel like I'm got deck collectors out for me. All right, are we starting? Are you guys in? Should I join? No, I don't know. I didn't write this one. Oh, you spin for your name. That's cute. All right, I'm not telling you who I am. Watch me get it wrong. All right, we good to go? Are we good to go? All right, I'm playing, so I'm not going to read out the questions. A bit too swift, it says. That's so rude. Did I get it wrong? No. I'm in 5th place. Oh, I gotta go next here. We don't need to discuss this, do we? No. Or if you did true, you probably just got true or false confused. I don't know. That's me. How did you guys beat me? That's impossible. What? God, this is hard. Kahoots are hard. Oh, I got it wrong. I put 5. You did too? I is 0, while next is not null. Add 1 to I. So I starts here. I guess it's 1, 2, 3, 4, and then the next is null. And then the next is null. Yeah, I guess so. Damn, that's humiliating. Why did so many of you do 8? Oh, well, we know it's returning I, so it's counting. So 4 or 5 is a better guess. But clearly I was wrong too. Now I hate Kahoots. All right, question 3. I'm in 6th place. Why is it a runtime error? Someone new? No, someone new. Current is null, and you're trying to dereference a null pointer, right? Yeah. Which, by the way, guys, is what the hypothesis is for what caused the CrowdStrike issue. Did you guys read that? It was a C++ null pointer dereference. And actually, yeah, we were thinking of making snarky comments that they should have used DCC because it doesn't let you do null pointer dereferences. But yeah, Google it. CrowdStrike, it's more complicated than that. But basically, someone didn't have a null check on a pointer dereference in C++. They should do COMP1511. Yeah. They were probably USID students. All right. I got to get back on the leaderboard here. What does this list look like after the function is run with 3, 4, 5, 6 null? What? What the hell? I don't know, that was a guess. This is hard. I didn't realize what I was putting you guys through. I put yellow. Let's have a look at it a bit slow. It's the time pressure. Okay, current is head, while current next is not null. So we're going until the second last node. Yeah, right, second last node. Then this part is what threw me. Then boo is just the, I don't know why it's called boo, but boo is just the temporary pointer to get current to next, and we free current. So we're freeing the second last node. So 3, 4, 5, 6 now should be getting rid of 5. Wait. Should we diagram it? Because I was ready to be like, that's wrong. And I get why you get so angry when the Kahoot question's wrong. Oh, come on. I didn't write this with Kahoot. Should we just do it like this? Maybe? This one? So it was 3, 4, 5, 3, 4, 5, 6, x. 3, 4, 5, 6. No. I'll just do x. It's not an array, so we don't have these indices. All right. Whoa. So what are we doing? So we're saying current equals head. So this is right. Current is head. While current's next is not null. So we say is next, is that null? No. So we loop. Well, this is not great. Okay, we loop there. Next, that's not null. So we loop here. Next is null. So we stop looping here, right? So current stops here. Then we make a new pointer to point to current.next. I think this is where I got lost. That's 6, current.next, right? Because current is pointing to 5. Current.next now becomes null. So I guess that in a sense becomes, well, that's not quite true because it's a linked list, but anyway. And then we free boo. So we remove this. So it should be 3, 4, 5. No, yeah. I mean, 30 of you got that right. That's quite impressive how quick it is. It's really tough. Okay, good stuff. Oh no, my thing's gone. Oh, I'm disconnected. Okay, what will this code output? 3, 4, 5 null and 6, 7, 8 null. Jesus. You got it wrong? You got it right. I was just slow. This one's not too bad. We got 2 linked lists, 2 pointers to the heads of each linked list, current 1 and current 2. We're looping through the second linked list until we get to the end. Whoops. Until we get to the end. And then we're saying that the last linked list's last node, final node, points to the start of the first one. So it's 6, 7, 8, 3, 4, 5. Yep. But a lot of you got it too. Oh, well, not really, actually. Most of you didn't get it. All right, next question. Quiz. that was a bit of an easy one. Head is the pointer for a linked list. Post condition, the function has done some manipulation of the linked list, and the linked list might now have a new head node. So we've got to return back the pointer to head. So it's got to be a struct node pointer, which most of you got. All right, very good, everyone. Are you in the room? Did you guys place? You did. Who are you? Bald Eagle? No, you're Daring Ant. Who's Bald Eagle? Online? Who's Smooth Cat? Congrats. You're a new winner, right? First time winner? Look at that. Okay, who's Bald Eagle? Are you online? Or is it Angela?
No, it's on me.
Guys, Kahoots are hard. Yeah. Yeah, I'm too slow as well. Sorry? Slow and does it tell me what I came? How do I know? You're kidding. So I could have won. We don't know. What a rort. It just says nothing is impossible. And then it's trying to get me to download the app. All right, good stuff. God, that is stressful though. Let's see, did we get more MyExperience? 22%? Lovely. Wow, this is the slowest website I've ever seen. 1% of you have done it. Well done. All right. All right, guys, where are we at with this bookshelf program? Has anyone followed? Yeah? Some people? No? Did you move seats? What do we want to do with this? We can do some more to it. I was thinking of doing some file IO stuff, but we can do another run through of the insert function to try and make some sense. We can diagram. Do we want to whiteboard the insert function? Will that help? Is anyone online saying anything? Do we have any input? No? Good chat. Who understands this insert function of the bookshelf? Do we want to whiteboard it? No. One yes. Can we do a poll? What's the quickest way we can get a poll going? Can you do them on the forum? YouTube? These guys just need to go to YouTube. Can you poll if they want to do a whiteboard of the insert function or add stuff to it like file IO? Ooh. It's live? Right? So if you're in the room, you can go to the YouTube live chat thing and vote in the poll. Or you can throw your hand up and we'll try and compare. Something's weird's happening with the mic here, I think. Anyway, what are the responses, Brianna? Coming? I'm gonna shut that door. All right, who's winning now? Oh my God, 52. You guys really are undecided. Or they're just like 8 votes. Oh. All right, last chance. Is it still 52? 54, let's whiteboard it. I think it's a good idea to do it. All right. So I should have taken a linked list one, I think. All right. Okay. What I'm going to do here is say title is like a genre is like horror. Oops. All right. Okay, let's have a look here, everyone. So here is our bookshelf linked list structure, okay? We're running the insert book function, and I've just copied the part that does the traversal. So this is ignoring the empty linked list check, yep? We have some books in memory. We've got, this is the shelf. It's pointing to a horror book with the title of A, okay? This is pointing to a crime book with the title of B. This is pointing to a crime book with the title of C. This is pointing to a fantasy book with the title of A, which is pointing to null. We're all happy so far? All right, good. We're inserting a crime book with the title of CA. Yeah? And this is the code to iterate through. All right? So what's the first thing that the code does? What's the first thing that the block of code does? What's the first line? Who said that? Creates current, and what does it point to? Shelf. Exactly. And shelf points to which book? Yep. So it's like that. Why don't we make this like red or something? Cool? Yeah, that's the first thing that happens. All right. We have a print statement. Let's not worry about that. And that it's not letting me move it. That's all right. Whoa. Maybe that's a bit better. All right. What's the next thing that happens? Guys, keep the chatter down in the middle, please. So you said move current through the list until it reaches its own genre. Let's actually break down that. You're correct. Let's break down the if statement and see. Let's do it like time by time because there's not too many. So it's while current's genre, which is what's the genre at the moment? What's current's genre? Genre. What's to insert's genre? Well, this is to insert here. Yeah, crime. So is horror not equal to crime? Okay, so we loop. All right, that means that condition is true. We said we're not going to worry about printing. So we say current is equal to current.next. We're just iterating through. That's it. And we do that loop again. Is crime not equal to crime? No. So we actually finished this loop already. This loop is completed. Got it? Now, is this the right spot to insert the book? No. But the loop is still, that first loop is still finished. Very good. All right, now we have a second loop. Yeah? Let's not overthink it. Let's just follow what the loop does. What's the first thing that it does?
Checking the current next data genre is equal to the insert genre.
All right. So let's just break that down. Current's next genre, which is crime, is that still equal to crime? Yes. And so that component of the while statement is to make sure that we're still looping through crime books. We don't want to loop past, we can't stop checking that we're in crime now. So now we're like looping, first we're finding the crime section, now we're looping in the crime section. So now that we're in the crime section, this is the really important check that checks are we in the right spot within the crime section. And it's comparing, okay, the next book's title to the current books. So it's comparing the title C to CA. All right? If C is greater than CA, we should loop again. So is C greater than CA? No, CA is greater. Yeah, that's right. So both of the conditions were what? True, which means what? We loop again. We loop again. Yeah. Which means current is equal to current.next. And we do the check again. Is the current's next genre matching crime? Current's next is fantasy. It no longer matches, which means we stop looping. So we stop looping in this example where current is equal to this book. Then all we're doing, the code's not copied here, is we now just insert the book in between. Remember, Malik's wherever it wants to go. We set the next to equal this, and we set its next to equal the next of where we were previously pointing. I know those lines are a bit confusing. This is super confusing. What's going on here? We delete current at that point, so that goes there. Why are there two coming off here? That no longer points here. It just points there. Right, do you see that? So we go A, B, C, C, A, fantasy book, null. Whew. Did that help? Oh yeah, question? Guys, please, the noise, please.
If two insert on title is less than current data on title, wouldn't it less than zero? Shouldn't we check whether the string comparison is less than zero? Because we need to check if the next title is greater than the first. We need to loop until it's failing that particular case.
We need to loop while the next book's title, or we need to loop until the next book's title is less than the current book. Because if it's less for the first time, we've just gone to the point after that book. So we need to loop while the next book's title is greater. Because when that fails, we've now for the first time reached a point where either the genre doesn't match and it's time to insert, or we've gone past it alphabetically for the first time. Got it? This was a pretty tricky, would you say? I mean, it's not too bad, but it's not straightforward. You need to think about it. And there might be imperfections here. I think there's some edge cases we haven't covered. Any more questions on this? Nope. To be really clear, this is harder than a linked list hurdle exam question. So do not worry that this is like the bar for passing the exam. This could be maybe what, a question 9? 8? 8? Angela, maybe? 8 or 9? Not a hurdle at all. Yeah. So if you're sitting here really stressed that you need to do something like this as a linked list hurdle question, you don't really have to worry about that. But just think there's 3 questions after question 9. No, 2 questions now. 10, 11. 2 more questions. So. All right. We do have 15 more minutes. I was going to, I guess you guys can either, I don't know, head off early because you seem a bit stressed out, or we can do file IO stuff for 10 minutes. Assignment help. No, that's what the help sessions are for. You can go to the help session after this if it's running. What are you guys thinking? No, next week. Next week. That needs way longer anyway. What do you guys want to do? A lot of blank faces. Do you want to leave early? Yes? Do you want to? Okay. Go. All right, I'm getting nothing from you guys. Go and take a break and a breather. That gets an applause, does it? We've got 2 lectures left, Monday and Wednesday next week. One of them will be doing a full exam review, and one of them will be talking about the future a little bit. Cool? All right, I'll see you guys on Monday. Have a good weekend. Please look after yourselves. Get to bed on time. I'll see you guys on Monday.